Hey guys, this is the video for homework number 6, which we had a topic at the beginning of the week, MHY, which was a review of factoring. So if you need help on that topic, that would be something you could go backwards with some of these videos for and review that way, or you could just search for something like the X method or factoring, polynomials, something like that. What we're moving on to today is the quadratic formula. And so for some of you, I think this is going to be easier. Plus, I can show you an awesome way to look at it. So I'm going to clear all that off. Basically, this is the quadratic formula. So first of all, just to point out a couple of things. This is a quadratic equation, and it's written in standard form because it has equals 0 on one side. Basically, all of the quadratic pieces have been pushed over to one side of the equal sign, and then the other part of the equal sign, the other side, has a 0. And so you'll notice that you end up with an x squared term, and then you end up with, here we go. So we have an x squared term here, which has a number in front. And then we have an x term here, which has a number in front, right? And then you also have a constant term here at the back. So we've been looking at these for a while. This is not a brand new idea. But the piece that you're pointing out is that there is these 3 different coefficients, the number in front of the x squared, the number in front of the x, and the number that's by itself. And those 3 numbers are the numbers that we're going to use in the formula. So basically, I'm going to take the a out, I'm going to take the b out, I'm going to take the c out, I'm going to plug them into this giant formula here. So the formula x equals negative b plus or minus. So this symbol here might be new for you, but it means positive and negative. So this represents 2 solutions here. This is where you get your 2 solutions. So when we factor, remember, and we end up with x equals whatever number and x equals whatever number, we have 2 solutions, right? Because it crosses the x-axis at 2 places. So here's one x equals something, and then here's the other x equals something. So this is telling you those 2 somethings. The plus this, when you do it with a plus in the middle, it makes one solution. And when you do it with a minus in the middle, it makes the other solution. So you're plugging in b, and then you're plugging in a, and you're plugging in c into this huge fraction that has a square root symbol, and then this plus or minus. So it definitely creates like a Pemdas. Oh, that's a b, not a p. Pemdas, like huge Pemdas problem. Is really what it is, right? It's really just a giant opportunity to practice order operations. I'm also going to show you that it's also a giant opportunity to practice using your calculator, because really you guys are in high school now. Every math class you take after this, you're going to be allowed to have a calculator. And really you should learn how to use the tools that you have available to you, right? Like if you had a shovel or a spoon, why would you use the spoon to dig a hole when you could use the shovel to dig a hole? And that's kind of how a calculator is at this point. So I'm going to show you one of these problems by hand, but I also am going to show you the same problem with a calculator so you can see how much faster that will make it. All right, so here's the formula. One of the first steps is memorizing the formula. Really, the more you use it, the more you're going to recognize it. But there is also a lot of math teachers will use stories to talk about that idea. So that's what I'm going to show you right now, is a story about a negative b. So notice that the equation starts with negative b. So this is supposed to be a story that helps you remember the quadratic formula. So I'll play this and we'll do a problem together.
Once, not so long ago, there lived a very negative bee. He always seemed to be grumpy and moody, angry and depressed, and very, very negative. No one knew quite why he was so negative. His parents wondered. His brothers and sisters wondered. His grandfather and grandmother wondered. Even his best friend wondered why he was always so negative. Perhaps he was just born that way, but it was as if a negative sign followed him wherever he flew. One day, the little negative bee's negativity became a bit more positive. He found out, to his great surprise, that he had been invited to the annual Bee Festival's radical party. This would be the most radical bee party of all time, and he was invited. How it happened, no one really knew, but the little bee couldn't wait to attend the most radical bee party of all time, as he had never been invited to one before. The day finally arrived. The negative bee flew to the hive and entered the most radical party of all time. Well, let me tell you, it is hard to describe a party this radical, but I will try my best. When the negative bee entered the hive, the first thing he noticed were bees square dancing. If you have never seen bees square dancing before, this is quite a sight. Music is playing. Bees are careful of their stingers as they twirl and whirl, swing around, left to right, right to left, up and over and up. Bees square dancing is an amazing sight. The next area of the radical bee party were the card games. Unfortunately, the bees were playing with decks of cards that were minus 4 aces, and this caused quite an uproar. Bees accused other bees of cheating or playing favorites. It is quite difficult to play cards when you are missing 4 aces, and the bees, like anyone else would, had a hard time of it. But the party continued, and the bees danced and played until they could dance and play no more. It was 2 a.m. when the most radical bee party of all time finally ended. Now, class, can some...
Okay, so now that we watched that video, then hopefully it kind of makes sense, the story. So the idea is that there once was a very negative bee who became a little more positive because he got an invitation to the radical bee party. And when he got to the radical bee party, he noticed there were bees square dancing and also bees playing cards, but unfortunately they just were missing 4 aces. So they had minus 4 aces. The party was so fun that it didn't get over, right? Over in a fraction, over until 2 a.m. So that story is supposed to help you memorize the formula. Okay, so let's go in then and actually try it. So the first problem that I got, and I'm going to start with one that's not on IXL at the moment, just because I want to show you. It was 5x squared minus 9x plus 4 equals 0. So if you were, so there's, keep in mind, there's different ways to solve a quadratic equation. One of the ways that we have been talking about, so method number 1 is factoring. And that's why I wanted to start with this example, because this example will factor. So, and factoring in some ways is a little easier because a lot of times it's kind of like numbers that are either like it's just kind of, I guess, rational numbers that can either be whole or fractions, where they're just kind of easy to deal with. If you have a different kind of solution, then that quadratic formula, this always works. So that's what's really nice about it, is that it works in every single situation. Factoring only works sometimes. So I put an asterisk next to it because it only works if you can figure out the x. If you can go through and do the thing we've been doing where we say, okay, 5 times 4, the product is 20, and then the sum here is -9. So I'm looking for 2 numbers that multiply to be positive 20, but add to be -9, and that would end up being -5 and -4. So -5 times -4 is where I get -20 or +20 from, sorry. And then -5 plus -4 is where I end up getting that -9 from. So those are the two numbers that work for that. So really what that means is I need to take these two numbers and I would rewrite this. So I have 5x squared and then the +4 at the end, right? These two pieces, the first piece and the last piece. And then this piece in the middle, I'm going to rewrite with this. So I have -5x minus 4x. And then I can factor by grouping. So this is a review of what we've been doing. So really, I guess this would be that topic MYH. So then if I factor this by grouping, I put the first two together and say, okay, well, I can take 5x out of both. That leaves behind x minus 1. And then here I have a negative sign. So I can take, looks like 4 out of both. So -4, which leaves behind x minus 1. And so then when I factor, I get 5x minus 4, and then x minus 1, which equals 0. So if I'm solving for this, then x equals +1, right? Because I'd add 1 to both sides here. Or if I add 4 and then divide by 5, I also end up with x equals 4/5. So hopefully you have practiced this enough times that that makes sense to you. What we're going to look at today is what happens if you do this same process. What if you solve, but this time you use the quadratic formula, which is awesome because remember the quadratic formula always works. So let's go over here and use the quadratic formula. So I have, remember, the -b plus or minus the square root of b squared minus 4ac, and then that's all over 2a. So I'm going to first take out what is a, what is b, and what is c. So if I look through this, it looks like a is 5. Let's switch colors. B here is -9, right? I had that circled in green. And then if I look at C, that's a +4. So here are my 3 different numbers, A, B, and C. So it's just the 3 numbers that are across here in my equation. So I use that here. And so now I'm going to plug them into this equation. So let's go through and say, all right, x equals -b. So -9. Oh, that's what I wanted to do, is use the colors as I went. Actually, you know what? Here, let's do this. Let's write the shell of the formula. So -b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So now I'm going to plug all those numbers in. So a is 5, and so a goes here and here. B is -9, so I'm going to put in -9 here and here, and then C is just in one spot. It's over here at the end, which is a +4. So if I look through this, this is just PEMDAS. I have to make sure I understand the order that I'm supposed to simplify this in. So I could say, well, here, a negative times a negative makes that a +9. So really that's 9 plus or minus the square root. And then underneath the square root symbol, I have 9 squared. So -9 squared, right? So it's 81. And then 4 times 5 times 4. So that's 20 times 4, which is 80. So I'm going to subtract 80, and then I'm going to divide the whole thing by 10. So if I go through, keep going, 9 plus or minus the square root of 1 all over 10. And so that is, if I split this into 2 different equations, this is what I mean about the PEMDAS problem. I have 9 plus the square root of 1, which is 1, divided by 10, or 9 minus the square root of 1, which is 1 over 10. And so both of these reduce. This is 10 over 10, so 10 divided by 10 equals 1, or this is 9 minus 1, which is 8 over 10, which reduces to 4/5, which is the same 2 numbers I got here. So this is method number 2, which is the quadratic formula. So the thing is that factoring is easier in some situations, but it's only possible sometimes. Quadratic formula always works. All right, so if I go then, so this is a lot of writing, so let's clear all this out. If I go into the topic, so now I refreshed it, so it gave me a different topic. I end up with this t 2t squared plus 5t minus 7 equals 0. So what I wanted to show you now is I wanted to show you how you can use technology to your advantage. So I'm going to make this smaller, and then I'm going to grab Desmos. And what I'm going to do is I'm going to show you how to build this formula into Desmos so that you don't have to write it down every time and you don't have to do it on paper. Because overall, you have a computer that can help you. Get out of here. All right, so basically, if I build the quadratic formula in here, Desmos is awesome because you can put variables in. So I'm going to put in, let's put in negative b plus. So I'm going to do plus this time, but I'll show you in a minute how I'll change that. Plus the square root of b squared minus 4ac. Notice I'm just typing this stuff in. And then I'm going to put parentheses around this to make it like my numerator of my fraction so that I can tell the computer that I want this to be the top. And then I'm going to push divide. And then I'm going to put 2a on the bottom. So notice, so this is that formula, right? I just typed it in. I have the plus version here. So I'm going to select all, which I don't know exactly how your computer works, but if you push Control A, it will select all typically. And I'm going to copy it. And then down here, I'm going to put the same equation. I'm going to paste it. So Control V, but I'm going to change that to a minus sign. And so notice you have a slider here for A, B, and C. And that means you can change these numbers, what you want A, B, and C to be. So here, if I look at this first problem, I'm going to come over here and say, all right, well, A is positive 2, B is positive 5, and C is negative 7. So if I plug those numbers in, so let's say I come back over here and I say, all right, A, oh, sorry, I got to change my mouse. A is 2. So I can actually just even type that in if I want. So A is 2. B is 5. And C is negative 7. It tells me the answer is 1. And so here I'm going to do, actually, to be honest with you, I don't even need to put this one in here. I can erase that and then just change that to a minus. So if I change that to minus, it tells me it's negative 3/5, which negative 3/5 is the same as what we got at negative 5/4. Or that, oh, negative. Oh, I see, sorry. So basically watch. So I'm going to change this. It says you can do it to decimals. So my answers here are negative 3.5. Or if I change this to a plus, 1. Nice. All right, so now I'm going to come back. Let's try another one together. And let's even skip forward so you can see that it'll work if we get more difficult. Yeah, I'm going to actually clear all this out. Easier to see that way. So let's skip forward to a higher level so that you're convinced that you can handle it. I want to get one that looks like it's hard. Well, this one is a good one to try because I think there's a piece missing here. So some students will definitely get confused if you're trying to use this formula. In this example, A equals negative 6. B is this number in front here, which is negative 1. And then C is not visible, which really means it's 0. This like has a plus 0 here. So if I were to change these in my formula, then C is 0, B is negative 1, and A is negative 6. So if I put that in here as a plus, then I get 0.1666667 with the end, which means it's rounded there. And if I put in a minus, I get 0. So I know that one of these is 0. And then I wonder if you can convert to a fraction. Some calculators let you convert a decimal to a fraction, which is really convenient. Give me just a sec. Okay, I wanted to look up how do you change it into a fraction, but it's really easy on decimal. So if I go, so one of the solutions is 0, which I typed in. If I go back up to the plus version of this answer, this says 0.16667 with the end because that's a rounded 6. If you click this little symbol, it'll change it to a decimal, which is -1/6. Correct, right? So pretty easy. Let's do one more. So let's erase these. And then write in what we get for the new one. So for this new one, it looks like A is 2. Ooh, draw, please. So A is 2, right? And then B is 6. And then C is -9. So if I change in my formula, C to -9, B to 6, and A to +2, then I can see that the positive version is this number, which this looks like it's going to be a decimal rounded to the nearest hundredth, right? Because I don't even get the option on this one to change it to a fraction, which means it's irrational. It means this has some kind of square root involved with it. It was not a perfect square. So I'm going to round this to the nearest hundredth, which means I am focusing on the 1.098. So if I'm looking at 1.098, this number tells me to go up. Here is going to go up, which I think this means it'll be 1.1. I hope this turns out right. Hopefully. 1.1. If not, then I guess we'll be able to look at the answer together and see what it says. Oh, I need a mouse. 1.1, please. And then for this one, if I change this to a minus sign, then I get -4.098, which again, I think would round up to that 98 would round that up to a 1. So -4.1. So that's right. Yeah, good. Okay, so you can see that you're rounding it 2 places after the decimal. Hopefully that all makes sense. We can definitely go over some more examples the other day, but like I said, I have a feeling that some students are probably going to like this better based on the idea that if you do go into decimals, you can build this equation and just change this sign back and forth from plus to minus to find out what your 2 answers are. And decimals is what's embedded in your state tests and things too, so that's also good. Okay, let me know if you have questions. I'm sure we are obviously going to go over some more examples throughout the next week and a half, I'd say.